Hello students, good time to all. I am Chandan Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss electric field lines, its properties and representations. Let's begin. Before proceeding towards the topic, let I clarify. In this session or in the upcoming sessions, as the topic proceeds, electricity and magnetism, the concepts are very similar as we studied in case of intermediates, but the style of approach or the mathematical expressions and notations are different. Let us proceed to the topic. Electric field lines. An electric field line is defined as the path that may be straight or curved along which a unit positive charge moves when free to do so in an electric field. Electric field is the region in which a charge experiences a force is called the electric field, and that electric field is represented by the electric field lines, and that electric field lines is nothing, that is the path, and that path is represented by either straight or curved lines, and that is the line as the unit positive charge moves when free to do so. The properties of electric field lines. Property number 1, the electric field lines are directed away from a positive charge and directed towards the negative charge. Minus q. If there is a positive charge plus q, then the electric field lines are directed away from this, like this. These field lines are away from that positive charge. And from that negative charge, the electric field lines directed towards to that of negative charge. This is the graphical representation. And the electric field lines starts from positive charge and ends towards negative charge. Here the lines are starts from that of positive charge, but here the lines end at that positive charge. The electric field lines start from a positive charge and end on negative charge. In other words, we can say the line of force, that line of force starts from higher potentials and end at lower potentials. And another property, the tangent to the electric field line at any point gives the direction of that of electric field. If we calculate the direction, what should be the direction of that electric field at any given point in that of electric field? The tangent to the electric field line at any point gives the direction of electric field at that point. Direction of electric field at that point. Here is the electric field due to that positive charge, but if I calculate what should be the direction of electric field at that point due to that positive charge electric field, then we have to draw a tangent at that point, tangent to that of electric field at that point, and that tangent gives the direction of electric field at that point due to that particular charge. Okay. The tangent gives the direction of that of electric field at that point. Next property, two electric lines never cross each other. Two electric lines or electric field lines never cross each other. Is it possible to draw two tangents at a single point? No. That is the reason we can't cross two electric field lines each other at a given point. Next, property number 5, the electric field lines tend to contract lengthwise. That is the indication towards the two unlike charges attract each other, that is the two unlike charges means the opposite charges attract each other. attract each other. Okay, if there will be the positive charge, there will be the negative charge, then the electric lines are started from that of positive charge and end at that of negative charge, started positive, end at that of negative charge. Look at that figure. Here the electric field lines tend to contract lengthwise. That contract lengthwise indicates the two unlike charges, or we can say the two opposite charges are attract with each other. Next thing, when two charges are like or similar charges, then what happened? The electric field lines tend to exert lateral pressure. That is indicates the repulsion between two like charges. If we take two positive charge here, here is the positive charge, here is the another positive charge, then the electric lines of force like this. These are the electric lines of force away from that of positive charge, and this section we can say that exert the lateral pressure here. Here the tend to contract lengthwise, here it tend to exert lateral pressure. That indicates two dissimilar charges or unlike charges attract each other, whereas that indicates two similar charges repelled with each other. Next point, if we take a conductor, then there will be no such electric field lines inside that of conductor, or no electric field lines pass through that of conductor. The electric field lines do not pass through a conductor. And this explain absence of electric field lines or electric lines of force inside the conductor. Absence of electric lines of force inside the conductor. Next property, property number 8, the electric field lines are closer where the electric field is strong, and the lines are farther where the electric field is weak. If we consider this section, if the electric field lines are very close to each other, then at that point the electric field strength is strong as comparison to that of electric field strength when the electric lines of forces are farther from each other. The difference between electric lines of force are large, then the electric field intensity is very low. So, here we write the electric field lines are closer where electric field is strong and lines are farther apart where the field is weak. Where the field is weak. And if we take an isolated charge, the electric field lines are straight. These are the isolated charges and the electric field lines are straight. And if we take two charges, here the considerations are two charges. So, at that case the electric field lines are curved with each other. That is the basic reason. Here the electric field lines are straight as you take the isolated charge. Here only positive charge, that is only negative charge. But if we take two charges, then the electric lines of force are curved with each other from this two figure. Now, we represent the electric fields in terms of electric lines of force. So, the representation of electric lines of force. The concept of electric lines of force can be used to represent the electric field diagrammatically. The density of electric lines of force in a region determines the electric field intensity. Higher the electric lines of force, higher be the electric field intensity. Lower the electric lines of force at that point, lower be the electric field intensity. That is the reason the number of electric lines of force per unit area are proportional to the electric field intensity. So, the electric fields are of two types. By taking the strength of electric field intensity or the number of electric lines of force at that of given region or at that of point, we take in two different approach here. One is uniform electric field, and another one is non-uniform electric field. Non-uniform electric field. The uniform electric fields are represented as these are the uniform electric field lines, and the non-uniform electric fields are represented as these are the non-uniform electric fields. in case of uniform electric field has the same intensity at all the points, whereas in case of non uniform electric field does not have the same intensity at all points. So, in this way we represent uniform and non uniform electric fields according to the field strength or the density of electric field. So, with the help of this video lecture we understand the basics idea towards electric field lines. Here we define what is electric field lines and properties of electric field lines, and finally the representation of electric field lines. So, with this useful and informative notes, let me wind up this session. Thank you.